So, question 1.1. Solve for x. So they want you to solve for x for the following equations. 1.1.1, you have 3x minus 6 times x plus 2 is equal to 0. They want you to solve for x here. So, what does this, like when you're looking at this, that's saying find the value of x. But what value of x? Why? So, they want you to find the values of x such that they satisfy this equation. That's what they are asking you to do. Find the values of x that will satisfy this equation such that when you multiply this bracket by that bracket, you get to 0. Right? So, if you have, let's look at this. If you have x and y, the product of x and y equals 0. What you can say your x is equal to 0 or your y is equal to 0. At least one of them should be 0. So if you're multiplying two things and your answer is 0, at least one of them is 0. That's what you should always know. So, looking at these two brackets here, you have this bracket times that bracket, and you're told that the product of these two brackets is 0. What does that tell you? It tells you that at least one of them should be 0. That's what it's telling you. So that's how you look at this. So you want to find the values of x that will satisfy this equation such that this bracket is 0 or that bracket is 0. That's what it means to be solving your x here. So if you're saying, so now what this equation is telling you, I'm repeating this many times. It's telling that the product of this bracket and that bracket is 0. So what that tells you, either this bracket is equal to 0 or that one is equal to 0. So you say, okay, 3x minus 6 is equal to 0 or x plus 2 is equal to 0. Because if this bracket is 0, then the product of the entire thing will be 0 and this equation will be satisfied. Similarly, if this bracket is 0, that means the product of these two brackets will be 0. This equation is satisfied. So we want the values of x such that the product of these two brackets is 0. So for this part to be 0, that means your x. So your x, you must find the x value such that this bracket here is 0. So you transpose this to the side. 3x is equal to 6 divided by 3 divided by 3. Your x is equal to 2. So what this tells you is that for this bracket to be 0, your x should be 2. So if you take this 2 here, okay, let me just stop here. And then for this bracket to be 0, that means your x is equal to minus 2. So for this to be true, your x should be an element. Should be an element of minus 2 and 2, which is x should be in this set. That's what this tells you. And you're done with this one. Because you want the values of x such that this equation here is satisfied. That's it. You're done with this one. Let's go to the next one. So solve for x here as well. 2x squared minus 6x plus 1 is equal to 0. Correct to 2 decimal places. So that correct to 2 decimal places, which means this thing doesn't have like nice factors like rational like factors. So let's use the quadratic equation straight away. So we say, okay, my quadratic equation is called x equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So this part here is your a, and this part here is your b, and that part there is your c. Right? So x is equal to negative b. What is your b? Your b is minus 6. This part here. Plus or minus square root of b all squared, which is minus 6 all squared minus 4. A, what is my a? My a is 2 and my c is 1 all over 2a. What is my a? Is 2. Then you punch this in the calculator. Your x is equal to, or your x is equal to, punch this in the calculator, minus 6 plus square root of minus 6 all squared minus 4 into a over 2 into a. So we have x, which is 3 plus root 7 over 2, and x is equal to 3 minus root 7 over 2, and this one here is equal to 2.82, and this x here is equal to 0.18. These are your solutions for x. Just use the quadratic equation, straightforward. And then let's clean the board and move to the next question. So this is an inequality, right? Inequality equation. So first thing you do, transpose this to the side. So you have x squared minus x minus 90 greater than 0, right? So you want to find your critical values here, where this equation of yours is equal to 0. That's what you need to do. Find your critical values. So say we want, okay, our critical values for x squared minus x minus 90 is equal to 0. Factorize this, or you put it in a quadratic equation, because this is similar to 1.1.2, the one we use the quadratic equation. You can use the quadratic equation here if you can factorize. So x, we have 9, we have 10, minus, we have plus. So x is equal to minus 9, x is equal to 10. So your critical values are x is equal to minus 9 and x is equal to 10. So, but you want to find this the set of x values that will satisfy this equation, or equivalent with this one, because these are equivalent. So the one that I find easier is this one here. Find easier to work with, because this is a parabola, this one. So you can just draw a rough sketch of it. You can look, okay, here's my parabola. It will look like this. This is my y, this is my x, right? My intercepts at minus 9, somewhere maybe here. It doesn't have to be neat. And 10 is somewhere here. So to draw this, say, okay, it's a positive parabola. It has this smiley face here. So this should be 10 here. 10 here. 9 here. So 9 minus 9, 10. So this is our function, right? So you want the values of x where our function, this one, which is this, is greater than 0, which means where it is positive. Where is it positive? So here is positive because it's above the x-axis. Positive, 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 0 here. negative, 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 because it's below 0, right? Negative, negative, positive, 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 above the line y is equal to 0, because this is x-axis, right? X-axis or line y is equal to 0. This is the y-axis or line x is equal to 0. So here my y is equal to 0. Above here is positive, here is negative, right? So above here y is greater than 0. Here y is less than 0, below. And here on this line y is equal to 0. So you want where your equation is greater than 0, where it is positive. It's positive here and there, right? So what are the values of x then? So it's these values here. Let's say the values this direction. So those values are less than 9, and the values to that direction. Those values are greater than 10. So your x values, x is greater than 10, or your x is less than minus 9. Or you can write it x is an element of minus infinity, from infinity to minus 9, right? Union what? 10 to infinity. This is how this looks like, which means you're just taking the union of this set and that set, you're just putting them together. That's what you're doing here. But you don't have to write this, but that, because our function is positive greater than 0 here, which the corresponding x values are these ones, they're less than minus 9, and here the corresponding x values are these ones, greater than 10. That's how you do this one. Then you move to the next question. So you're asked to solve for x here as well, right? So the first thing to do when you're dealing with such things is to notice the relationship between this guy and that guy there. What is the relation between this guy and this guy? So if you look at it, you have x minus 7, x raised 1 over 2. You know from sets that square root of a is equal to a raised 1 over 2. We know this from sets. We did sets at grade 11. So this is that by definition. Okay, is equal to minus 12. Let's look at it again. What's the relation between this and that? So this is raised by half, and that one is raised by 9. It is raised by 1. So what you can quickly tell is that the power of this is 2 times the power of that. The power of this is 2 times the power of that. Which means what you have here, we have x raised 1 over 2 times 2 minus 7 times x raised 1 over 2 is equal to minus 12. Which is similar to saying this is the same as x raised 1 over 2, which is same thing, right? Minus 7 x raised 1 over 2 is equal to minus 12. This is what you have. Then you can transpose the 12 to the other side. So you have x raised 1 over 2 minus 7 x raised 1 over 2 plus 12 is equal to 0. If you look at this, should be a 2 there. If you're looking at this, you'll quickly realize that this resembles exactly what we had at 1.1.2. At 1.1.2, we had something along the lines of 2x squared minus 6x plus 1 is equal to 0. This had exactly the same shape, except that we have 2x, you can write it this way, 6x plus 1 is equal to 0. These two things are similar. And here you solve for x here, right? Which means here you solve for 1 over x raised 1 over 2. Because here you solve for x here when you use your quadratic formula. Here you're solving for your x raised 1 over 2, right? So what you do now, say, okay, I want to solve, I will solve the x raised 1 over 2. But eventually you must go to solving x. Someone else might use what they call k method. Let this thing be k and then solve it. So allow this thing to be k. Maybe I should do that. Should I? No, I don't want to. Use the k method if you can. But I don't want to do that. Let's just go straight to the point. So what we have now, say, okay, you can say factorize this or use your quadratic equation to solve x raised 1 over 2. I'll factorize it and say, okay, here I have this x raised 1 over 2 and x raised 1 over 2. This is minus 3 and this is minus 4, right? That means my x raised 1 over 2 is equal to, similar thing to what I said on the first question. This is the step we had in the first question. You want to solve for x raised 1 over 2, right? So for this, what if the product of this bracket and that bracket are 0, which means this bracket is 0 or that bracket is 0. So what we have here is, for this to be 0, or for this to be 0, this part, which is x raised 1 over 2 minus 3, should be 0, or x raised 1 over 2 minus 4 should be equal to 0, right? And then now solve the x raised 1 over 2 is equal to 3, or x raised 1 over 2 is equal to 4. But what do I want? I want to solve for x. That's what they asked me. So multiply by 2 there. There's 1 here, multiply by 2. There's 1 there, multiply by 2, multiply by 2. So this and that cancels out. You're left with x is equal to 3 squared. The side, you're left with x, because this and that will go out, is equal to 4 squared. X is equal to 9. X is equal to 16. This is what this means. Get your x. So the most important part is just recognizing the relationship between these two. That this is twice, the power of this is twice the power of that. Then you can split them and make them look similar. Once they are similar, you treat it as your 1.1.2 like type of question. And then this is it. Hopefully it's correct.